Okay. And I'm going to jump into, oh boy, where is VS Code? VS Code. There we go. So here, let me close that window. So let's say that I have some data that I need to, in one file, that I need to access in another file. So let's say I have this file here that I've just called sample data.py. We can put in some sample data. Let's say like my data is going to be a list of like numbers. I don't know what these numbers are from, and they probably don't have letters in them. Let's just do one more for good measure. So here we have like some data. Let's say maybe this was created or it was generated by a function or something in this Python file. But in my other Python file, which is currently blank, I need to be able to read that data and import it because that data is relevant to some functions that we create. Let's say, for example, like if we needed to check that the data, all the data points were like above 500 or something like that. So how can I get data from one Python file to another? So basically the easiest way to do this is to just import the data. Simple as that. So we can say from sample data, I can import, because sample data here acts like a Python module. So I can import my data. And just to confirm that that works, we can print out my data, right? So if we do this and I hit run, once it decides to run the code, as we can see here, it prints out this little array. Well, what's that array? Oh, great. That's exactly the same thing as from my data. Now, this is good, but there's a couple of problems with only sticking to importing data between Python files like this. Number one, we see here that I've got an additional folder created on the left called PyCache. How the PyCache folder is created whenever we import something in Python using a module. So again, note here, sample data acts as a module. Now, the only problem is, if I were to rename this file from sample data.py, like so, to something using like dash notation, like sample dash data, I would not be able to say from sample dash data import my data, because this is not correct module import format. And I can't put quotation marks around it because it expects a module name, which again can't have a dash, it can't have a space or anything, or quotation marks or anything like that. So again, we can import data from one Python file to another, but the Python file has to be named a specific way, and it has to be imported as a module. So the other problem, obviously, is this only lets us really shuttle things between one Python file and another Python file. What if I needed to say, let's say that I had some external like sensor that I was getting data from, and I needed to push the data from that sensor into Python. We don't have a way of doing that here. Or what if I needed to get data from like an Excel spreadsheet and send it to Python? Or let's say I'm running some Python functions and the output of those functions need to somehow get spit out onto a web page. Well, this from import method only lets us go between one Python file and another Python file and nothing else. Well, that isn't really helpful. So instead, what we want to do is look at new to us data types that let us basically go from one Python file or from any file type to any other file type. And one way that we're going to be doing that is by using something called JSON. So there should be some more information about this in the README for today. But JSON is a fancy word or a abbreviation for JavaScript, leave object notation. So what does that mean for us? Well, some things to note about JSON. First thing is it lets us store data and objects. Today, we'll mostly just be talking about the data aspect of it. It's also a specific file type. So it can be imported / exported, read, where you can read it, you can write it. And it's also very lightweight. So it's got a small file size for lots of data. So JSON files are basically written in a .json format. So I'm going to delete the PyCache folder. Don't really need that. Perfect. So they're written in a .json format. A lot of times, they're used especially in big data applications or machine learning cases. If you have, let's say, like a lot of test cases, or you're pulling like a extreme amount of data, like say you're getting a table with like millions of rows, or maybe not millions, thousands of rows from, let's say, an API or the internet. A lot of times the best way to store it is in a JSON format. Also, JSON is used, again, because note that it's JavaScript object notation. You'll see JSON used a lot to transport data from backend to front end. So what do I mean by that? Well, again, JSON, again, JavaScript. JavaScript is located on your front end most of the time. So if you're creating some data in Python, let's say you have an API that's getting data from like some sort of data server thing, and you need to find a pretty way to display it. You'll get that data through Python, for example, then convert that data from a Python object into JSON. And then that JSON gets opened up by a JavaScript file, which then converts it into pretty HTML that you can see on your front end. So it's essentially an intermediate. JSON is basically an intermediary for data storage purposes. So let's see if we can so also what I would recommend is, if you guys want to code along with me while I'm doing this, make a folder in your Platoon directory that's just like a demo data folder, where you can basically put in custom data files. So what I'm going to do is I'm going to create a JSON demo.json file. And there's a few things to know about JSON. So number one, as I said here, it's called JavaScript object notation. So object notation for us is essentially a dictionary, or I guess a more accurate way of saying it is a series of key value pairs. And if we remember, and if we think about why, if we remember how classes and objects are created, classes and objects are basically key value pairs and functions. And JSON is almost exactly the same thing. So the way that we write a JSON file is we don't really put in variable names into it. Like you don't necessarily define what the thing you're importing is. That's just the file name. But we start with an open and close curly bracket, and then we just start writing our key value pairs. So let's see, what's something that we could make a JSON file for? Let's say that we did like the example of a car brand, let's say. So we could have like the car's make be, I don't know, like a Toyota. We could have the model be like a Sienna. We could have the year be something like 2021. We could say like damage or is damaged, and we could, and that goes in quotation marks, and then we could set this to, I guess, like false if we wanted to. Let's see, I'm trying to think of what other things we could add. Oh, we could also do like a nested. We could also make a nested JSON. So we could say like, we could also put in an array or a list of owners. So we could say, let's say Bob and Anne and Chuck are the owners of this vehicle. And we can also nest JSON within other JSONs. So we could say, for example, yeah, we could do something like that, Grace. So I guess for that would be something more like package options. And then that would be something that you would configure within your Python file. Let's see, I'm trying to think about if there's any other ways to do it. Yeah, not really. Let's see, can JSON handle Booleans? Yes. So you could write this as false in quotation marks like I did there, or you can also write it in lowercase equivalent to JavaScript syntax. So you could say is damage is false, is damage is true, is damage is null. We'll say false for now. And I guess we could say also, what's another example? Yeah, this is probably good enough for right now. So as you can see here, we have our data structure for our JSON for a car, let's say. So this is great, right? We've created our JSON object, but we can't do anything with this. Because if in our JSON file, we can't run anything. Let's see. Rahalia, any specific reason you put in double quotes? Yes. So let's remove the double quotes. Well, that causes us a glaring error. Why? Because property keys.
The false statement. Sorry, I should specify.
Oh, yeah.
Yeah.
No worries. Yeah. So no, the false statement, I just did that initially just because everything else was in double quotes. But the false in quotation marks, is that going to be a string or a Boolean?
A string.
Yeah. So that one would be a string, whereas false in lowercase without it would be a Boolean. So that was just a stylistic or a decision on my part, but I think we can keep it as a Boolean just for example purposes. But you do bring up a good point about the double quotes though. And this is something I want to make clear. So again, if we remove the double quotes from this, and I just wrote make like so, note that again, VS Code throws an error because in JSON, every single property key has to be double quoted. Now, similarly, if you were to put in a string in your JSON, it expects a straight up value. So when writing pure JSON in a JSON file like this, if you want to put in a string, it has to be enclosed in double quotes. But if you're writing, let's say, a number or a Boolean or a list or / array, you don't have to do. Now, I guess one other thing that I did want to mention that I think I have an example for now is we could put in something like package options, which is something like what Grace was referring to. And this can be an example of nesting JSONs. So we can have package options, and this is basically just going to create like a nested array. So we could say something like, if this is basic, and we could say that this is false, we could say like luxury, and we could say that that's like true, and we could say like sound upgrade, and we could say like that's true, for example. One other thing to keep in mind is everything here. So this is going to be comma delimited. So comma separated. So every line has to be separated by a comma. You have to have semicolons between your key value pairs, curly brackets to open and close it. And JSON does not like trailing commas. So some other languages are okay with it if you keep an extra comma at the end. JSON, no. So just make sure that for your last entry in your JSON file, no commas on the end of the line. That was a very quick 101 of how the JSON file structure works. Do you guys have any questions about what JSON is before I start getting into how to import and I guess use it practically?
Are you
Okay,
assigning it to
so-
anything?
Sorry, go ahead.
Is it just going to be in between the double curly brackets? It's not going to be assigned to anything?
Yeah. So whenever you get JSON, JSON is, you don't really say like my JSON equals or anything like that. When you're doing it in the context of a straight up JSON file. And again, the reason for that here is it says it expects a JSON object, array, or a literal. So JSON, think of it, it's not an Excel file, but you can think of it as a dictionary without a name. So all the JSON file does is it stores our data for us. We don't need to give it a specific name. Now, how do we know that JSON is JSON instead of just random stuff? Well, one, the file extension is .json. And number two, the name, I guess, of the JSON that you're importing generally should be your file name. So like JSON demo would be the name of the data that I'm importing. But we also don't really physically assign the JSON data a name or for the variable, just because that's generally something that you'll set when you import it anyway. Any other questions about JSON? Okay, so let's start talking. Oh, wait, more chat stuff. So yes, so Chris, it is basically just one giant key value file. You got a bunch of keys, got a bunch of values. That's it. Instead of importing one-to-one. Grace, yeah, that's effectively correct. So a good use case for JSON in the real world is, so something that I use JSON for personally was getting large amounts of data from a time series. So basically, if you're like observing something in an experimental setting and you're getting like data like every like X number of seconds, you could have a JSON data structure for each observation that has like the name of the thing you're observing, the time of the observation, what you observed, and a few other characteristics. And you basically can create a giant list. You can have a bunch of JSON files, one JSON file for each observation. Or like in our car instance, for example, that you can have a JSON file for each car in your inventory. So Dave, we're going to get to how we call things. So hang on one second, but you're correct. Yep, it's basically just normal calling separate, call by reference syntax. When you have multiple files or just the one. So Chris, it really depends application to application. In this instance, we only really need to have one JSON file just because we're playing around and testing it. I believe the example in today's README has like a couple. So I think the one in the README, and you guys can feel free to look at this after, is like a school JSON. And that has like one JSON file for each student, which is definitely something you can do as well. But it really depends. You're allowed to have as many JSON files as you want. There's nothing really stopping you from creating a million of them if you wanted to. But it's really application dependent how many you use. Other questions?
I just had a quick question just to clarify. So within each JSON file, you're only ever going to have one outside set of the curly brackets, and you can nest things inside, but within each JSON file, you're only ever going to have one of those, right?
Yes.
Okay, thank you.
Yep. And I mean, we can try adding in another one right now, and let me just copy some of this in and see if it throws an error. And yeah, we see it doesn't really like it because it says end of file expected. So you can kind of think as like the opening and closing curly brackets as like your HTML closing HTML tags where that starts and ends the document. It kind of has a very similar principle. So Dale, the point of JSON is to give you a nice, easy way of storing data that you can open up in different programming languages for different applications. So again, like if you were to get data, let's say that I had an API that pulled data about a car. Now we could pull that data in to our Python file, and then, or we could pull that data in as a JSON file, like download that JSON file, and then open it up using Python. And Eric, yes, a lot of APIs use JSON for the simple reason that JSON, I mean, it's a lot simpler to use than other data storage methods that we'll talk about shortly. But it's also just nice and compact file size storage wise. And so yes, it's basically just one giant object, and there's only one full top level object per file. You can't add multiple. You have to import them. If you want to have two JSON structures, you got to have two files for them. So let's see how this works in practice in Python now. So Python, very handily, has a JSON library for us by default. So you can import it using import JSON. Let's say, yeah, it's a subject of JavaScript syntax, it's a lightweight data interchange format. And there's a good number of functions, as you can see on the left, and this is not a full list of them. But we'll talk about a few. So the first thing that we need to do whenever we're dealing with JSON is quite simply just importing JSON. Next thing that I want to do is I want to make a variable for my file name. So we could say like import file name. Because I like to distinguish between my import and export files. So I'm going to say that this is located in demo data /JSON demo.js. And then after that, let's see. So we've got our JSON imported, and we've got our file name. So now I can define let's call it car data. And I can do JSON.load, and I can load the object. So what does .load mean? So again, we can read through what it says here. It's going to deserialize, or essentially break down our JSON or key value pairs into a nice normal Python object. So if we type JSON.load, we can go import file name, and we can print out car data. So just to see what happens when we do this. So let me move this to one side. We hit run.
Is that on line 10? Is it importing the JSON file or the JS?
Yeah, thank you for that catch. It was supposed to be JSON.
Okay.
That explains why it says string object has no attribute read. Thanks, Jesse. Okay, let's try that again. String error has no attribute read. Oh, okay. I forgot one other thing for this. So we can't just import the file directly on its own. That's why it's saying string object has no attribute read. What we actually need to do is first open the file name with read capabilities. So because again, JSON here is a file, so we have to open the file and return a text stream that can then be loaded in as JSON. So we have to open the file and then import it in read mode. So just to explain what I'm doing here. So we need to load JSON, which is the JSON.load part from file stream in read mode, whose source is import file name. So basically what this line here is doing is we're going to the JSON demo.json. It's going to say, okay, I'm going to recognize that this is a file and that this file has stuff in it. It's going to start creating a stream to that file, which is going to read from it. And then with JSON.load, it's going to say, okay, this is a JSON file with JSON stuff. I need to read it in with JSON format. So let's try running that again. Okay, let's do that. Okay. Hooray, no more syntax errors. Great. So let me just clear my terminals. That way we don't see everything else that looks super ugly. And Ethan, go ahead.
Isn't the default to read it, so you don't really need the R? Or is that just good, like good to have?
Well, let's say that I forgot the R, but I actually wanted to write my file instead of read. And I forgot to put anything there because I was like, oh, default behavior. Then 300 lines later, I go and try to edit it. I can't edit it now because I've opened the file, but it's only in read mode. So it's just good practice to specify what your mode is. So again, as you said, if we look down here, it says mode is an optional string. It defaults to R, which means open for reading in text mode. And again, you can write to it, you can create and write, you can append. But in my personal opinion, I just generally like saying R, just so that we have it. But again, there's a bunch of different options. I think somebody mentioned in chat R+, which is another good one to have as well. But it's just good practice to write it, just in case you forget later.
Thank you.
Yep. Let's see, other questions. Can we modify JSON demo by accessing car data, or is car data now just the copy? Yes, you should be able to modify JSON demo by accessing car data. But we're going to get to that in a little bit. So the first thing that we're going to do, though, is just mess around with JSON a little bit. So now that we've got our car data, let's look back at our file here. So this is in JSON format. So we've got, again, our key value pairs in JavaScript object form. Now, if we look down here at my console with everything I just printed out, we can see that basically turns this guy into a Python object that we can manipulate. So let's say that I wanted to get the model of my car. I could do car data, and then I could get model, like so. And if we run that, we see that indeed, we get that the car's model is a Sienna, which is exactly what we expect, right? We can also get all of the package options in the car by running the exact same thing, and just with package options. And then that's going to return a nested dictionary for us. We can get a list of all the owners. And let's say if I only wanted to get the first owner, we could do owner 0, because again, owners is basically just a Python list. And we see that the 0th owner of the car is Bob. And yeah, so if we're accessing JSON, it's relatively simple for us to do. It's just the exact same way. We access JSON in the exact same manner that we can access a normal Python dictionary. Let's see. All right, well, let me catch up on the chat real quick because I just saw like a bunch of notifications. Okay, so we talked about writing. Ever want R plus that we can also edit the JSON? So for in terms of editing JSON, generally you don't really add or append to a JSON file. Instead, what we usually will use is the dump or dumps option. So here, I mean, we can talk about how to do that very briefly if anyone wants. So let's see, I'm trying to think about what the best way would be to do this. Here, let's create, just for kicks, we can create a second file here. Now we could say like JSON output demo.json. We'll keep this file blank for now. So again, here we've got our car data, which is in a nice Python format. So let's say that I now have to change this. I need to, let's see, what's something we could do with this car? Okay, we can set, let's say that we now need to set the number of seats in our car. So we could do something like car data num seats, and I think they have like 8 seats, for example. So we could print out our new car data. Let me just comment these two out and make sure that num seats is something that actually gets appended. And we see that number of seats actually does get added to our car data right here. But if we go back to our JSON original file, that hasn't changed. So we can edit the data that we load in separately from our JSON file. Let me edit or add to the JSON file. Generally, you don't need to edit a JSON file directly, just because of the usage of JSON. So JSON is generally just used as an intermediary for input, output / data storage stuff. It's not something that that in most applications I've seen actively edit it or add to. There are ways to do it, but most of the time, the only things that you'll really see in JSON being used for is just reading everything from a JSON file and writing everything to a JSON file. So hopefully that helps a little bit. Yep. Okay, so we've changed up our car data from this file, right? Because again, we've added a new attribute. We're saying that the number of seats is 8. Now, this doesn't end up updating our original JSON.demo file, but let's say that again, now that we've added our, hey, the number of seats in this car is 8. I need to find a way to get this information from my Python file to, just for practice, let's send it to another JSON file. So the best way to send information to a JSON file is by using the JSON. You can either use JSON dot dumps or JSON dot write. So the best way to do that would be, say, let's with open, and we'll open, let's do it in my JSON. We'll do demo data / JSON output demo, and we can say like as output file, and we'll just specify that this is going to be in write mode. So this is going to, again, creates a new file stream in write mode for our output demo file. And it says that this is the output file. We can then run a JSON.dump operation. So what does JSON.jump do? So it serializes the object. What object? That's going to be our input object as a JSON formatted stream to our file pointer or to our file stream. So basically what we're doing here is I'm saying create a new file stream to our output file in write mode. Then when I say JSON.dump, let's say I'm sending car data and I'm sending that to output file. And I think that's all we need to write there. So what the next line is doing is that was not supposed to happen. The next line is basically going to convert our Python object to JSON serializer, send, or I guess you could say like dump serializer into output file stream. So Dave, this does not create a new file when ran because I've already created this JSON output demo.json file over here. So it doesn't create a new one. It'll send it to our new file, hopefully. If it doesn't, well, that's a little bit problematic. So let's run this and just make sure it works. It looks like the code didn't run with any issues. And if we go to our new output file here, we see that indeed it's imported our car data but modified with the number of seats as 8 to our new output demo file. Grace, that is actually a very good question. So a file stream is basically a way for us to access all the properties of a file. So it's essentially a way that lets us read, write, and open files. So if I were to like go into, let's say, like my file explorer and open up like a Word file that I had saved in my computer, there's a lot more than just double tapping and then the file opening than we see on the front end. So what happens in the back end is it'll create a file stream that'll essentially unlock the file and give us the ability to get data from it, or if we put right permissions, to push data to it. And that's why I included the with open over here. Because it opens a file and it creates, like, I guess you could say, like a stream of data about the file that we're reading, that we're analyzing. And again, that stream of data it's generally just like bytes, but it could be in read-only mode, it could be in append mode, it could be in write mode, whatever setting you set at the end. And file streams are not just a Python thing. You'll see them across a lot of different languages. You'll see this used in C, Java. I'm pretty sure like system IO for command line stuff. And Grace, exactly. And here's one. Let's say that all of the documents on your computer were open all of the time for different streams for reading and writing. That does not sound very efficient. So that's why you have a way to turn on and off file streams based off of what you're accessing. So I know here I haven't actually closed any file streams, but we could do that. Let's see. So we've got with open as output file here. Well, actually, yeah, all of these are, well, if you wanted to break it down a little bit more, we could say like our import file stream is going to be this guy. And we could just say that this creates the file stream. Then we're loading the data in from there. And generally after, okay, let me say import file stream. Generally after you import your data, it's a good practice to just do import, to close your file stream, which you just do by saying import.close, and then that will just closes file stream. If you want to break it down even further. But generally, you can just combine everything together and it's usually fine. Is there some background code that makes sure you don't write duplicates? If you run the code twice, the data isn't written twice. So when we are ill, the reason that it's not writing to it twice is because I've got the W set here. When the W basically will override the contents of your file. So let's say I changed it from the number of seats 8 to, let's say, the number of seats is 6. It's going to write, it's basically going to replace everything in my file with whatever I'm telling it to push in. So if I'm now saying to push in something where the number of seats is 6, it's not going to say, oh, I've got somewhere where the number of seats is 8. Let me also add something where the number of seats is 6. It's basically just going to like put a giant eraser over the whole thing, wipe out the whole file. And if we look at the file output now, it's only got one JSON object where the number of seats is 6. And again, that's just because of how writing works. Writing will overwrite your file with whatever you tell it to put in. But also, so Michael, to answer another part of your question, remember that JSON files only contain one JSON object per file. So imagine the chaos that would happen if you tried to append more JSON objects to a file, to a JSON file that already has one in there. It would throw a bunch of syntax errors. Zekun, that's a good question. I'm actually not too sure, just because in general, you don't really modify existing JSON files. But let me see. Because the main functions that are used for JSON files are either dump or open and read. So what I would personally do, because it doesn't look like there's any easy way to do what you're asking right away, is I would read the file in read-only mode or read plus. Then I would close the file stream. Then I would open up a new file stream to write to the original file with whatever modifications I want to make, and then overwrite the entire file and then close that. The only way that we can append it without overriding, to answer your question, Dennis, is to basically, so with the open, when you say with open, that'll create, again, it creates a new file stream for our either our input or our output file. So when you create the new file stream, you can basically sort of like hit like the pause button in your file stream where you want to insert or add new data and then resume it using, I think it's seek is the method you'd be looking for. But personally, I would not advocate doing that necessarily, just because it's more convoluted than simply opening the file, reading in everything, making some changes, and then just overwriting the whole file. And that's generally the method that's used. Yep. Let's see. I'm just trying to see if there's anything else I should talk about before going for questions one more time. Oh, so there's a difference between JSON.load and loads and JSON.dump and dumps. So let's go ahead and look at the difference between these. So if I type JSON.load, which is what we did earlier, this will deserialize a file stream or a file pointer, right? So let's write this down. Where's my things? JSON.load takes file stream as input. But there's a very similar looking function as JSON.loads with an S. And this, what does it say here? It says deserializes S, a string byte to bytes array instance containing a JSON document to a Python object. So what JSON.loads does is it takes in JSON written as a string as an input. So what on earth does that mean? So if I were to say, let's see, let's say I have like my JSON, and then we make a JSON thing here, and we could say something like 1 and then 1 and then like test and like 18 or something like that. What we could do is we could say, so this is like my JSON string, then the actual JSON, if we wanted to convert this string that is written in Python format to actual JSON, what we would need to do is say my JSON is JSON.loads and then read in the JSON string. So this is again, load and loads have literally a 1-letter difference. But if I tried to run, for example, JSON loads, and then I ran, let's say I ran a file stream like this, and we hit run and give it a few seconds to run. Again, this is why we get a type error, as the JSON object with a string, bytes or bytes array. Why? Because again, he said loads, not load. If we said JSON.load, just like we did earlier, there will be no problem. So JSON.load takes in a file stream as an input. We're going to use that 99% of the time. JSON.loads with the S takes in JSON written as a string as an input. So why on earth would we write JSON as a string as an input? Well, you could have a function that takes in some data from another structure and outputs it as a JSON string. There's also another function. So we've got, remember, we have JSON.load and JSON.dump. So both of those take file streams as inputs. But there's also JSON.dumps, again with an S. And the difference between JSON.dump and JSON.dumps is that the .dumps with the S will output, let's say, the contents of my JSON string to your file. Whereas dump will only take it'll only take the Python object So it's a little bit of a weird difference, but if you ever see people using dumps or loads instead of load or dump, that's basically what's going on in the backend. So don't get, it's not a syntax mistake, but it is a crucial difference. That's honestly about it for JSON. Do you guys have any questions about it before we take a quick break and do an exercise? If you had two JSON files, I want to put them together. Load one is just car data. 80, you could definitely do that. So why don't we do that right now, actually? So let's delete some of this. We'll keep that stuff at the bottom. We could say, here, let's make ourselves a new JSON. We could say JSON demo2.json. And let's just say, let's clear this, save that. No. And let's say, I don't know, we could say like leather seats could be like true. We could say like fancy things is going to be like false. And we could say like color as like purple or something like that. So if we were to, we now have the second JSON file, right? So we can load up, let's create, let's get a new JSON. We could say, what's a good place to do that? Yeah, here, let's do it down here. So we could say optional package data is going to be, and let's copy this, and we'll change this from import file name to demo data / JSON demo2. So we can print out our optional package data just to make sure that we're importing it correctly. So let's run this real quick and make sure we are importing it correctly before we move forward. So as you can see, we're importing our leather, we're importing our fancy things and color. So that looks great. So now what we could do, just like you said, is we could say car data, we could create a new field called add-ons. And we could say that this is equal to our optional package data. And we can print out car data after this. So again, for right now, that'll just nest a dictionary within a dictionary. So if we run this, again, we see here that it adds add-ons as a field within our car data dictionary. And again, here we've written this out to our JSON demo output, which is here. And if we go all the way to the right, we see that indeed add-ons has been added to nest JSON within our JSON file. So you're more than able to do that if you wanted to. Okay, any other questions about either JSON reading, writing, editing, the JSON file structure with code that, or the JSON file structure, anything like that?
Can I just see the Python code one more time?
Sure, any part in particular?
Oh, right there. Thank you.
No problem. And I'll pop this code in the Slack channel as well. Once we break.
Also, I have a question. Like a line 38, like with open as output file. The output file is like optional, or we can name it. We can name it anything we want, or it has to be like an output file.
No, you can name it whatever you want. You can name it the sky is blue, and then just make sure to change that in here. It does the same thing.
Oh, okay, cool. Thanks.
Yep. But yeah, the only reason that we're writing it like with the with open as format is just because it makes it basically a temporary variable. So like just while so it's basically saying, all right, I want to temporarily really quickly open this file, call it the sky is blue, dump stuff into it, and then close it. So that's why we use the with open format. Any other questions? Okay, so why don't we take a 9-minute break? We'll come back together at 10:50 here, and we'll reshare my screen. So we have a bunch of different types of ways to store data, right? An easy one is going to be like we've got text files, right? So the pros of text files is we can store basically anything in a text file. The cons of text files are they're relatively unstructured, and they're a little bit ungainly to deal with. But the main thing that we don't like about text files is that they're basically unstructured. So, okay, well, what else can we do? We can then talk about CSV files, right? Or comma separated values. So the pros of comma separated values are, again, they have structure, right? Unlike a text, like a normal text file. And they also allow us to store many types of values, right? You can store integers, you can store float values, you can store times and dates and other stuff. But the cons are, it basically is only like I would say it's like a 2-dimensional data storage. Like you basically only have rows and columns. So you can't nest data or have multiple levels. Very effective. And again, in Excel, you have features where you can have like one cell linking to a cell in another sheet and stuff, but that's not really like default comma separated values behavior. So again, like we said, like in a CSV file, you can have a bunch of rows which are instances and a bunch of columns, which are all your properties, but you can't say one property is an entirely new thing. It's just like one property that's like a number or a string. It can't be a property, can't have sub-properties to it. So JSON or JavaScript object notation, the pros of JSON are it lets us nest data / have multiple levels, right? It's structured and it can stores many types of values. So it sort of like gives us the benefits of a CSV file and text files with that. The only cons of JSON is each JSON should be in its own file. And crucially, there's no way to link JSON files or objects together. So if we go back to our social media example, JSON for that, we had, again, like names, we had addresses, emails, and so on. But for the friends list, JSON doesn't give us a way to link friends to each other. And that is where SQL comes into play. Our SQL is going to be our structured query. So real quick, what the benefits are for SQL are the pros. It's structured. It puts things basically into tables. It stores many types of values, and it lets us link tables together. So the cons of SQL are weird syntax. It's not very fun to deal with. Nesting is also a bit awkward, but there are ways to do it. That's really about it. So these are like the big four types of data storage that we regularly use. Well, types of data storage, common use data storage. Then there's other files like pickle files, which are like a .pkl, which are kind of like CSV files, but not. And there's others as well. But these are like the big four: your text files, your CSV files, your JSON files, and your SQL databases. Also, so SQL has tables, but they're all in one singular database, which is really good. And yes, pickle files. That is the actual name. We're not going to talk about them here, but if you want to go into a deep dive about what pickle files are, they're basically like Python's version of a JSON file. So if you're interested, feel free to look it up on your own, and I'm happy to field any questions about them, but perhaps outside of class time. Okay, actually, why don't we take like a short 5-minute break before we jump into SQL? Because I noticed that a decent number of folks are taking a break. So we'll take a 5-minute one, and then we'll jump back into SQL stuff. Seeing the recording. So just like we just talked about, for the benefit that SQL has is it gives us a structured set or a structured place to put our data. It can store a ton of different types of values, and it stores the data in tables. But crucially, SQL is a type of RDBMS, which is like a relational database, I'm going to say management system, which is a really complicated name. Basically, the relational part means that we can, don't need to save it. We can connect between.
Frozen.
Oh, thank you. Okay, is it unfrozen now? Maybe.
Yes.
Yeah.
Okay, sweet. So SQL, again, is a type of RDBMS. An RDBMS is a relational database management system. The relational means that you can link tables and databases together. The database part is basically just like groups of tables. So like right now, for example, in the example that you guys just did with the users for your social media app, in Python, each user is a separate thing. Like user 1 is not related to user 2, it's not related to user 3. They're all under the user class, sure, but there's no easy way to get all of the users associated with your program. What SQL does, though, is SQL creates a massive database of everything inside it. So if you create a table for your users in SQL will store every single user that you create inside of a table in one of its databases. So it helps you keep track of instances of your classes and instances of your objects very easily. And again, the other benefit is that it lets us link items together. So with JSON, you can't do that. CSV's pretty hard to do that. In SQL, if you have a user that has an address and you have a separate table of addresses, you can link the user to the address table like this. So that's the main benefit of using SQL over JSON or CSV files, at least in this case. Now, one thing that makes SQL a little bit more ungainly, and this is something we'll talk about later, is it's difficult to share. So harder to share SQL databases. So for like a JSON or CSV file, I can literally email you a JSON file or email you a CSV file. For SQL, it's not that simple. There are ways to do it using like web servers, and that stuff we'll talk about later on. But in general, that's one small complication with SQL. So, okay, I've been talking about SQL a bunch, but how is SQL actually useful? So I'm going to switch over to my browser for a second. So can you guys all see this pretty little flowchart diagram?
Yes.
Okay, cool. So this is a nice example of something that SQL can let us do. So, for example, here, this is very similar to the class that we created, right? And this is using a website called dbdiagram.io, which is something that basically lets you turn pretty flowcharts into actual SQL code, which is super helpful. I highly recommend bookmarking this because you will be using it. I recommend using it tomorrow, and you may end up using it over the next few days as well. So we've got our users tables here, right? This looks really similar to our table or to our user class that we made, right? We've got a username, role, and it's got a created at date. But let's say we wanted to get all of the posts associated with that user. So we can create another table of posts that has the ID of the post, the title of the post, the body of the post. But how do we link posts to users? Oh, here, let me delete. Let me see if I can delete. Okay. Here, we'll just pretend that this doesn't exist. So we'll only focus on users and posts for now. The way that we can link our users and posts tables together is by linking the user ID to the post. So what this is basically saying is, let's say I have a user whose ID is 1. Then in my posts, I can write a bunch of posts and have like a list of like 50 posts. But we can say post 7, 13, and 36 are all created by the user whose ID is 1. And this just inextricably links the user whose ID is 1 with all of the posts made by that user. Similarly, you could have a users table and like an address table. In your address table, you could have like street address, city, state. But let's say you have multiple users who live at the same address. So you could create another field in here, and that other field could say like address ID, and then that would link to the ID of the address. So you could have 3 users that are all associated with the same home address, for instance. So this is kind of where the cool features of SQL really start to shine. So I know that was pretty quick, but does anybody have questions about that? Okay, if not, let's start talking a little bit about how we actually use SQL. So I know I'm jumping around just a little bit, but trust me, this is important. So now you guys should all be able to see my terminal. I'm going to assume that's the case. All right, cool. Yes. So the first thing to note is whenever we use SQL, or in our case, using Postgres, we need to switch our shell user. In my case, I'm using my WSL Linux shell. For any other Windows users, you'll probably do the same thing. For those of you on Mac, you'll just use sudo to switch your user. So what I'll do is I'll type sudo -i -u and switch to my Postgres user, going to enter my sudo password, and now I'm in Postgres. So Postgres is basically the thing that lets us run SQL and SQL commands and create databases, and tables, and access them, and all that other sort of cool stuff. It lets us do that on our computer. So first off, does everybody have Postgres installed successfully? Okay, cool. If not, talk with one of the instructors over lunch, and we can help you work out the installation. So, all right, so we're now in Postgres. We're now in the Postgres user. How do I know that? Well, it says Postgres right here. So now I'm in Postgres. What can I do with my Postgres user? Well, this lets us connect to PSQL, or the running PSQL instance. So if I run that, we see that Postgres SQL or PSQL is running. We see the version's 14.8, and it looks like it's working. So again, we see our Postgres right here. So what can we do with Postgres? Well, there's a few things we can do. The first thing, there's a few commands, I guess, that I should run through first. The first one is that we need to create a database that we're going to work in. So I'm going to call this, let's say, create DB. We'll just call this like test database for now. So I now have a test database. But what can I do with this test database? Well, if I type, let's see, exit out of this, and we're still in Postgres. So now if I type PSQL and I do test DB, oh, sorry, that's why there was a problem. I need to do create DB outside of Postgres, or outside of PSQL. There we go. Okay, so create DB, so the database should be created. And if I run PSQL, we now see that I'm back in my PSQL. But whereas above, the first time that I ran PSQL here, it just said Postgres in there. Now it says test DB, because test DB is a database that I created, and I've now entered into that database. So what can we do next? Well, I've created my database. So let's see what's in it. If I've just created my database, there should not be anything inside of it at this point. So we can run /d, and it said it didn't find any relations. What does that mean? Well, if there's no relations, it means, again, remember that SQL is a relational database management system. So if there's no relations, there's no tables or databases, or there's no tables inside of our database. So there's a few things that we can do inside of SQL in order to change this. So there's a bunch of commands that we can run. One of the most important ones is create table. So let's say create table, and we can call this table, let's say test table. And we can have, we need an ID, which is going to be our serial primary key. And we'll talk more about what this is tomorrow. We'll add in, let's say, a message, and we can make this, let's say, a varchar. So a varchar is basically saying that like the data type of this is going to be a string. And yeah, we can just do that much for now. So let me walk through what I just did. So we did three things. The first thing we did is said, okay, all right, I want to create a table in my database. This table, we're going to call it test table. Now, this table is going to have, each row of this table is going to have certain properties. The first property that's going to have is it's going to have an ID. It's going to have an ID number. And that ID number is a serial primary key. A primary key basically means that this is going to be the thing that we refer to as like the primary first column. The next thing that's going to have is it's going to have a message. And that message is going to be a variable character thing of length 255, which basically means it's a 255 character long string. That is not null. And we can set that to be whatever we want. And then out here, we get this output that says create table. And indeed, we see that this has created a table. And that's how we can create a table in Postgres. So to make sure that this table actually shows up, we need to, again, run /d. And we see here that we get we now have two relationships. The first relationship that we have is our public test table, right? So there's a schema, public schema. It's a test table is the name. The type is a table. And the owner is Postgres. Why is the owner Postgres? Because that's the user that I'm signed in with. I'm signed with a Postgres user. And it also creates another table, or it creates a sequence, which is all of the IDs in our test table.
Umar, I'm sorry.
Generally,
are we supposed to see something other than the your other screen? Is there something else? Am I the only one that doesn't see the background screen? I only see the console.
oh, that's only the console, yeah. Yep, we're only looking at the console right now.
Oh, okay, I thought you were showing something on somewhere else.
No, but just to make sure, you guys can see like the list of relations and stuff at the bottom, right?
Yes.
Okay, perfect. So yeah, again, so the test table ID sequence at the bottom just basically tells you like what things are in, or what IDs are in your table. It's not really important for us right now. And honestly, it's not really something we're gonna deal with very much later on. But this is something that's good to know about. So, okay, this is how we can create a table. How can I see what's inside of my SQL table? Well, for that, we have another command. And this one is going to be the select command. So what select means is, well, basically you're selecting data from inside of your SQL table. So all our commands, by the way, in SQL in general are run in all caps. So if you want to say select, type it in all caps. Then to say that we're going to select everything, we're going to say select star. Now, where am I going to select from? Well, I need to specify which table I'm selecting from by saying from. And then lastly, we're going to say that I'm selecting from test table. And we can hit enter. And okay, the table is blank, which is exactly what we're looking for. Now, you also might ask why I'm putting a semicolon at the end of this. If we don't put it, it's not going to output anything. So in order to return an output, like something that we can physically see, we need to use a semicolon in order to return that. Why in the terminal and not our IDE? Chris, that's a good question. Honestly, I prefer to deal with Postgres in my terminal instead of the IDE. It's just a personal stylistic thing. You guys are more than welcome to do this in your IDE if you'd like to as well. There's absolutely no harm in that. But at least I find when like learning about Postgres initially, just doing it from the terminal is a little bit easier. Like, does it matter if you're in TestDB or Postgres for these commands? Yes, it does. So here's why. So if we go back, well, actually here, let me see if I can just quit database. So there's three places that I can run, or I guess two main places that I can run commands from. The first one is just in my Postgres user in my shell. When I'm running things from my Postgres user, I can't run SQL commands. So again, the SQL commands are things like create table or select star. I can't run those commands because I'm not in a database. So the only time you run SQL commands is when you're in a database. The thing I can run in here is like creating a database, like we did above, where it was like create DB, test DB, to creating my test database. You want to do that outside of your PSQL shell environment. Similarly, from here, I can run PSQL. And when I run PSQL, you want to say which database I'm running it in, and you say I'm running it in my test DB database. So from there, now I'm inside of PSQL. And as it says here, I'm inside of my database. Once we're inside of the database, I can now run all of my SQL commands. Okay, so Jesse, and all right, not sure how you create a user. Okay, hang on. I'm gonna stop my share for a second. Would anybody? Yeah. So the first thing, does anybody? You guys are on Mac. Okay. Well, I guess that creates a wee bit of complication. Let me see if I remember how to access Postgres via Mac, because I don't know too much about how to do that. I think you should, for Mac folks, you should just be able to type PSQL and then space and then Postgres, and that should work. So are Mac folks still getting an error if you try that?
That way I was able to go into it, but I didn't know if, like, I was trying to follow along with like the create database and then like do the PSQL test database, and nothing was coming up. So I thought something was wrong. But if I just run like the PSQL Postgres, like it puts me in Postgres. But that sudo part, I got like an error.
Okay, gotcha. Yeah, the sudo part is only for the WSL, the Windows Shell Linux folks. So you should, after that, if you try just doing PSQL Postgres, you should be good.
Should I have something pop up separately when so once I'm in Postgres, like I do create DB, test DB,
Right.
in order to see like how you had your table come up? Do we type in something different? Do I just type in like test DB instead of like the PSQL?
You should type in, well, actually, do you want to share your screen? We can probably go for there. It'll probably be a little bit easier.
Yes. No. Okay. Oop, no, not that one. Can you see
Okay.
this?
Yeah. So, all right. So you created, so you did PSQL. Let's see. I'm just trying to think about what the best way is to do this, because I'm not too well versed in the Mac stuff. So what I would say is, first, can you just type /D just so we can see what's been created inside of it?
Do I need backslash or forward slash?
Backslash. Yeah. Okay, so that did not okay, so that didn't end up creating any databases. So what you'll want to do now is just type create space database in all caps.
Like that?
Yep, and then give your database a name. So test DB, for example. And the name is generally in lowercase. So SQL syntax, like I said, is a little bit weird, but basically all your commands are capitalized. Everything else should be lowercase. So if you run create database test DB and now put a semicolon at the end of it.
Oh. Do I need to just type that again?
No. So now your database has been created. So once you run that, your database should be created. So type the /D again. Interesting. Okay,
Is
what
it
if you
right?
do,
There should be a semicolon.
yeah, what if you retry it with the semicolon? So also, instead of retyping the whole thing, this goes for anybody when you're in your console, you can just use the up and down arrow keys to get to the previous and next command. It makes it a lot easier.
And then just do like a colon like that.
Semicolon.
Okay.
Semicolon, yep. Syntax error at.
Is that like when I had that up there?
Oh, that's weird. Okay, why don't you try, can you try typing in \Q and then type the PSQL Postgres again? And now rerun create database test DB with the semicolon. Okay, perfect. So now you've got the database created.
Okay. Thank you.
Yep. So other folks on Mac, are you guys able to run that okay? And I guess WSL folks, are we good as well?
Yeah, I ran it alongside you guys, and mine is working as well.
Okay, perfect. So again, just to recap. So for Mac people, do the PSQL Postgres and then create database in all caps, which is really weird and annoying, but it is what it is. For Windows /WSL folks, you'll want to switch your user to Postgres using sudo. And then once you're there, you should be able to do the same thing with you should be able to do PSQL, or you should be able to create database using create DB, or you can also do the create database inside of PSQL as well. Okay, Roger, you're having trouble. Do you want to share your screen as well real quick? And then after that, if anybody else has trouble, feel free to troubleshoot during lunch and we'll move on. There isn't really too much left in lecture, so we'll wrap that up quickly.
I don't want to hold y'all back. You can continue. We'll take care of it later.
Okay, sounds good. We can jump into a breakout or something after. So yeah, let me just go back to this because there's not too many other things that we need to get through. So once again, so we've just talked about creating our databases, right? So again, for the Windows people, you can direct type create DB, or you can do PSQL, hit enter, and then after that, create database. For the Mac folks, PSQL, hit enter, then create database. Once you've created your database, you want to check the interior by doing /D, and /D should initially show you with nothing inside it. Up here. Then we talked about how we can create a table. So creating tables is always done once you're logged into your database by doing, again, PSQL and then the name of your database. Then we can create a table. We can call this test table. Now we can link the ID with a primary key. And remember, the primary key is a default thing inside SQL that is just a syntax thing that basically says that we're going to use this as the main. I guess you could sort of think of it like an array or a list index sort of thing. And then we can create any other features after. So one that we created, for example, is message, which is a variable character field. So basically it's going to be a string of length 255 that is by default not null. And then we can wrap it up with a closing parenthesis and a semicolon, and that creates our table for us. Then if we do /D again here, we see that we get our list of relations one more time. But before, when we didn't have anything created inside our database, it said there were no relations, but now we have two relations. One is our test table, and the other one is our sequence of IDs, but we don't really bother about the sequence of IDs. Now, how do we see what is inside of our table? The way we do that is SQL likes to use a select notation. So we'll say select and then star, basically meaning everything from where are we selecting from? Test table. But there's nothing inside of test table right now. So now since there's nothing inside of test table, how can we add something to test table? So the way that we can do this is by using the insert into command. So I'm going to say, let's go here. We can say insert into. And what table am I inserting into? I'm inserting into test table. Now, what am I inserting? I'm inserting whatever it is that goes on top. So I'm inserting an ID and I'm inserting a message. You'll notice that this format looks not really. It looks decently similar to when you're creating a new instance of a class in Python. So remember, when we're creating a class, you run your init method, and your init method basically says like self.id equals the input ID, self.message equals the input message. This is basically the same thing. But here we're saying insert into instead of making an init method. We're inserting into our test table here. We have an ID and a message field, which are the fields from this guy, from our database. But what are we inserting into those fields? Well, we need to insert in some values. What are our values? Well, for our ID, we can attach an ID of, let's say, 1. And we can say the message is something like, hello world. And also SQL does not use double quotes. This is something important to keep in mind. SQL basically always only uses single quotes. So if you're taking notes on SQL, I would recommend jotting that down as well. And then at the end of this command, we can put our semicolon. We run this, and it now says insert 0, 1. What does that mean? Well, that basically means that it's run successful. Or to be a little bit more specific, it's inserted our values into our table. But how can we check that it's done this? Well, number one, let's still make sure that our table exists. So we can do /d, our table still exists. And now we can rerun our select star command. So we can say select star from test table, which again says, hey, give me everything inside of our test table. We can run that. And we now see, remember before, this thing had 0 rows. Why? Because we didn't have any data in it. Now we have 1 row. We have the ID is 1, and the message is hello world. So to be very brief, this is how we can add things into our SQL databases. Are there any questions about how I did that?
I got a question real quick on when you're creating table. I tried to create table and it works, but I'm curious. So like if you scroll up to where you initially created the table and you put ID and message, yeah, right there. How did you put that big? Did you just do a bunch of spaces between ID and serial primary key? Or because
Pretty
I
much.
tab and nothing really happened. Like, okay, so you just put a bunch of spaces between them. Does it matter like how you separate ID and serial primary key or
I
anything?
think it just needs to be more than 1 space. And then it should auto format it like that.
Oh, okay. So you just need to do it multiple times because I put 1 space and I was like, okay, I probably shouldn't just put a bunch of spaces.
Yeah, generally a bunch of spaces, or if you were, so the other, also this goes to another thing to mention as well. In addition to running SQL in your console, you can also run it from your IDE, like people said. And there's also .sql files, which is something you guys are gonna be playing with in the exercises for today. And in the .sql files, you can use tabs instead of spaces because it's not in your console. It's like a file that you can edit. So that's what I would recommend doing when working on the exercises themselves. But in your console, a bunch of spaces, it should autocorrect.
Thank you.
Yep.
Hey,
Any
Omar,
other question? Yeah.
can you elaborate on what the difference is between the Postgres equals to the Postgres dash. I noticed I was trying to do an insert into when I was on the dash. It was giving me a syntax error, but it put me back into the equal stage, and now I did it again and it worked.
Okay. So are you saying like between this and that, basically?
No, so there's the Postgres or the your test DB right there. You see your test DB where you have select star? Yeah, right there. Yeah.
Yep.
So
you mean
between
like the
that and the dash, what's the difference? Because obviously it's acting differently.
Oh, okay. I see. The difference is, well, the select star from test table, I didn't put a semicolon, so it didn't actually return or do anything. But, and then that's why it goes back to the single dash, from my understanding. But I'm actually not sure. That is a good question, though.
Is it easier to work with the terminal? Is that why we're working within a terminal instead of like just a file?
I just personally prefer working in the terminal for SQL, or which is why I'm doing it in the terminal. But again, most of the stuff that you guys will be doing is in the IDE going forward from tomorrow.
Okay, so we'll be making like function calls and stuff from our actual files, and it'll be pulling in information from these databases essentially.
Right. Yes, but there's also an important distinction to make too. So remember that SQL databases are only and only databases. So they're not, a SQL isn't a language that we can really like write functions in. But what we will be using this for, I guess I'll say this real quickly and then basically wrap up. What we will be using SQL for is something that we can interface with Python. So when we write Python code, we can tell Python using Postgres, hey, go to this database, get me stuff from this database and turn it into Python things, and vice versa. Yeah, Joshua Bax, go ahead.
Oh, I'm sorry, I didn't mean to raise my hand. Sorry.
Oh, no worries, you're all good. Any other questions?
So where's this all stored? We create this database, right? Where's this at? We're in a Postgres user, right?
Yeah.
Where's the data being stored at? Physically?
So it's stored basically again in your computer. From my understanding, though, the databases are located in like a special database dictionary, database directory. I think that's set by default as a memory location, as a location in your file structure. I think the variable is like PG data or something like that. But basically, it's set at a custom place that you set when you first install Postgres, and that's something you can change in your environment variables, I believe. But I would not recommend that.
So is there a way to display all the databases that you created?
That I'm not sure about, but let me check. Display. And I know you can definitely list all of your tables. We using the listing all of your tables within a database uses the /d command. Okay, so it looks like to list all of your databases in SQL, you can use the /l command. This, if that's something you want to experiment with, you can do that. And to answer Jake's question real quick, so SQL is basically only used in the front, in the back end. So remember, SQL is just a database. It's a place that we store stuff. We can use it to, we can pull data from it and push it to the front end. But all SQL is it's a bunch of tables and databases and nothing really related to prettyifying a website. So there's one last thing that I'd like us to learn how to do. So let me just go back in to my test DB real quick. So remember how we created a table? So we've created our table called test table, right? We also want to do some, we also want to, if we can create tables, I'm pretty sure we can also remove a table. So in order to remove a table, what we'll do is we'll say drop table. Then we have to give the table a name, and the table we're going to drop is test table, put a semicolon. Then we get our confirmation message saying that the table's been dropped. And to confirm that, we can do /d, and it doesn't find any relations. And then you can just type /q to quit. So the essential functions for today's class that we want to remember: create table, create your table. Select star from your table, selects everything in your table. Or if you do select star from table where, you can add in conditions to basically say, I only want this, not that. But that's stuff that you'll learn about more in the reading for today. Drop table takes away your table and deletes it and all the data inside it. And then insert into, which we did over here, insert into will put values inside of your table for you. That's about it for SQL. All right, let me catch up on the chat real quick. Where's the chat? There we are. Okay, so that was list. I think I just missed a question. Let's see. Yeah, so to delete a database, you'll want to use drop database or delete database and then say the name. Any other questions? So yeah, again, you can see here, I mean, I just went into PSQL. You can type, you're in your Postgres user. I dropped my database test DB, and that database doesn't exist anymore. And I can try accessing that database by saying PSQL test DB, and we see it doesn't work because it says that test DB does not exist. So dropping your table drops the table, dropping your database drops the database. And remember, an easy way to think about it is like databases contain tables. So databases are like the big high level thing. Any other questions? Alrighty, awesome. So I'm going to go ahead and stop the share and stop the